Hello guys, welcome to Ace Coding. In this video, we are going to see the Leetcode problem number 1704. Determine if string halves are alike. Let's get into the problem. So the problem states that you are given a string S of even length. Split the string into two halves of equal length and let A be the first half and B be the second half. Two strings are alike if they have the same number of vowels. So the vowels are nothing but A, E, I, O, U and the corresponding capital letters of the vowels. And note that S contains uppercase and lowercase letters. So return true if A and B are alike, otherwise return false. So we are given a string S of even length. We need to split the string into two half of equal length and let A be first half and again B be second half. So two strings are like if they have same number of vowels. So vowels may be lowercase or uppercase, and string will contain lowercase and uppercase characters. So we need to return true if A and B are alike, otherwise false. So let's get onto the problem definition. So yeah, we'll see the first step for solving any problem is to define the problem clearly. So we'll define the problem first. So the problem is we'll be given an input string yes and output is nothing but true or false, that is whether the string is uh, that is split into two, and if we are they are alike, so we'll consider this as string is splitted to alike parts. So this is the output we need to check. So these are the input and output of this problem respectively. So what is alike parts? So alike is nothing but they have defined. So we'll go step by step. So they'll be given the string S. So S of even length. So the string is split into two halves, halves of equal length. So A and B. So two equal halves. So it's nothing but A is string's first part and B is second part of the S. So second part can be mean like second half of S. Same goes to part 1. So first half of S. So yes, we need to split them and we need to check whether the splitted strings are alike. So two strings are said to be alike if they have same number of vowels. So after splitting this up, we need to check the number of vowels in each part. So number of vowels of A should be equal to number of vowels of B. So this is the condition for alike. So this is the condition for alike. So what we will do is we'll just need to count the number of vowels of A, that is first half, and number of vowels of the second half. So yes, so the vowels are including both the lowercase and uppercase characters. That is our uppercase vowels, and the string will contain lowercase and uppercase letters. So yeah, lowercase and uppercase are present in string. So vowels are nothing but the words, I mean the characters A, E, I, O, U, and the corresponding uppercase characters are also considered here. So we'll check this for string count of these vowels in string A and string B, and finally we'll check the equality between them. If it is equal, we'll return true. If not equal, we'll return false. If it is equal. So this is the problem definition. So now let's move on to approach this problem. So second step is approach. So a string will be even length. So the part A will be half of. So let's consider the length of string as n. So first n by 2 and the second n by 2. So n by 2 is these parts, and A will contain the position. The let's say the we number the position of characters present in S. So let's consider a word A, P, P, D. So for this, we'll consider the position of each word, each characters. So we'll say this yes, and these are the positions. So string S will be having the first part, which is 2, 1 and 2. So it will start with 1 and end with n by 2. So n is the last, that is the length. So it ranges from characters 1 to n by 2, and B will range from characters n by 2 to up to n. So n by 2 plus 1, sorry, n by 2 plus 1 till n. So these are the characters. So in order to find the count of A, so how can we find the count? So we need only the first n by 2 parts for n by 2 characters for A. It is a part A, and next one n by 2 part for part B. So we can keep two variables and iterate over the complete string, and firstly find out the number of vowels in part A, and next we'll find the number of vowels in part B, and finally we'll check the equality. This is the approach we are going to use. So in order to find this, initially we'll have A count as 0 and B count. So these are the steps to be followed in this approach. So A count and B count is going to be 0, and we'll find out the count of vowels in characters of S, that is in the range of 1 to n by 2, and store it in A count, and next we'll find count of vowels of S, that is given string S in range of positions like n by 2 plus 1 up to n, and after finding this we'll store to count B count. So we'll store it. So after storing this, we'll return the equality of A count, which is number of vowels of A part and B count. So this will be the answer. So these are these steps, and we'll discuss the time complexity and space complexity. So complexities. So when it comes to time complexity. So the time complexity of this approach will be we go of n since we iterate over the complete characters present in yes one time, so it will be big of 1. And space complexity is big of 1. We use constant space since we used just two variables, we didn't use any extra space. So whatever the value of n, so n here is nothing but length of given string yes. So the space complexity here is big of one less constant because even if we have any value of n, the space used to be big of one, just two variables. These are two variables, and the space complexity will be big of n for any length of the string. So the approach for this problem is nothing but uh, store that is computing values or sum. So this is the approach used here. So these are the approach, and we are going to dive into the coding session. There you will get the clear idea of how to implement each of these steps. So let's move on. So initially we'll have a variable a count and variation is to 0. We'll have b count and it is to 0. We'll store the n as a stored length, and we'll iterate I over range 0 to n by 2 plus plus. So if we'll store take the current character. The current character is nothing but a start character at I. So if its current character ch is vowel, so we'll pass it and get using a helper function. If the current character is vowel or not. So if it is a vowel, we'll increase the a count. So from this we'll be able to deduce the count of vowels in part A, and now we'll write it over the part B. It is ranging from n by 2 up to n. So we'll take the current character, and if current character is a vowel, we'll increment b count. So finally we'll return a count equal to b count. So we'll write the helper function of which vowel. So private boolean vowel get the current character ch. So if current character any of this, so we'll take this up and store it in a constant. So character array, so we'll mark this as constant. We'll call this vowels, new character array of service cost. So each vowel will what it will do is it will check whether the current character is a vowel or not. So slide it over each character in vowel. This vowels is a global variable. So we'll check if current character equal to a vowel, we return true, or if the current character matches didn't find any match in the given worlds, will return false. So this is all about our approach, and you can minimize this by writing a new function. So here we have repeated codes. So we can find, let's say, find vowel count. So it's a helper function, and in this you can pass the string and start and end variables. So for what we'll do here is we'll just take a count equal to find vowel count of string s and start and end by 2. So we can avoid this repetitive code. So we'll start I from start and end in in. So here we'll pass, yeah, I less than n. So finally we'll return count. So we'll have the count variable as initialized to 0, and we'll increment the count variable. Finally we'll return this. So we can also simplify the b count by find vowel count of s comma n by 2 and n. So this here. So yeah, let's take this up. It's working fine for ample use cases. So let's submit it up. Accepted. And yeah, that's all about this video, guys. Thanks for watching this video. Have a great time.